Thank you very much for Frank's introduction. So today I want to share some study we are working on for the evaluating consistency of adult problem-solving behaviors across different items using the PIAAC process data. So from the introduction, that is a digital assessment platform in PIAAC provides the possibility to collect the process data, especially the action sequences and response times. So just similar like the first two speakers has already mentioned quite a lot of things about action sequences and response times. And also we find the process data is especially helpful in understanding respondents' behaviors and strategies in problem-solving items with the scenario-based designs. And because of the complexity and high dimensional structure of process data, so most studies focus on analyzing one single item. For example, in our previous studies, we only focus on one spreadsheet items or one this kind of web-based items. This is for the LAMP return. So by giving to say, we only focus on one item and we are considered about to say how the people actually to have the consistent behavior when they come into different items. So we want to see whether we evaluate the behavior consistency across items renders a possibility capturing and modeling person-related latent characteristics. So the research goals in this study is the first one is to investigate whether the consistent behavior patterns could be identified by process data features. So that is what are the consistent behavior patterns. And second one is we want to understand the association among the consistency of behavior patterns with cognitive competency and background variables. So that means we want to understand what kind of people are in each behavior pattern. So for this research, we put them into 3 sub-studies. The first one is we use the aggregate level response process variables. So we focus on 2, the number of actions and response time, because these 2 are majorly used in the previous studies and to show the informative when we to make the classification or clustering for the people's behavior. So in the study 2, we will use action sequences with the similarity computation. And the study 3 is we do the mapping the behavior patterns by problem-solving competency and background background variables. So for this study, we focus on a small sample size. And so that is, we only focus on the US sample by the 1,340 test takers. That is only routed to the second module of PSTRE items. So PSTRE items is the problem solving in technology-rich environment in PIAAC 2012. So that means we will focus on the 7 items there. For each respondent, actually they go for the fixed sequence of these 7 items. And we have 629 female test takers. So that is almost 47% in the sample. And we have around 53% of the male test takers. And also we have the mean age of our sample is around 39.2 years. In this sample, we have 680 test takers. So that is almost 50% had an educational level above the high school. So that is actually, you can see that is pretty high level of the education. And then we find there are 3 cases that had technical issues in this sample, so we have to remove them. So finally, we got 1,337 test takers in the final sample. For the instruments, and we can see actually we have these 7 items starting from U19A and U23X. And actually here, the book order just now, I think Caroline has already mentioned this item here. So for these 7 items, so we will do them by the fixed order. And you can see they have different content and they have come into different environments. For example, they have spreadsheet, web, and email. So that means generally we will design each item by a specific certain interactive environment. So how can we get the consistency across these kind of three items. There are three types of items, or what kind of items actually we will focus on. So for this study, the first one, we want to use the aggregate level variables. So that is number of actions and total response time. So we listed here of the number of actions and response time for each item. So you can see actually from the number of actions, they have a different mean value. So some items they do very using very long sequences like the U02, they have 24 actions, but some items they will use short actions that will be good enough to finalize this problem solving task. For example, like in U19B, is only in the medium level is only 11 actions. But of course, you can see there are some outliers, like the maximum, they use 260. And in the response time, so we also can see the people will use different patterns when they solve the items. And our idea is to put the number of actions and response time by 2 dimensions, and to put each individual into this 4 quadrant. So the first quadrant, that is they use the longer action sequence and also the longer time. So that is by their medium level for each item. And so the second quadrant, that is we use shorter action sequences, but still long response time. And the third quadrant, you can see that is use a shorter action sequence and shorter time. And the last one is quadrant 4. So we use the longer action sequences and shorter time. So for each item, we will put each individual into this 4 quadrant. And also you can see we put them into the 7. So we calculate to see how many times the person located into this quadrant, and to put this in the most quadrant time as his final quadrant. But at this time, we also to say the respondents need to have at least a half of their assigned items to be 4 out of 7 items to be in the same quadrant. So for some example, like to say, for example, the first person, if he comes into the quadrant like this, 1, 2, 1, 3, 1, 1, 1, so that means he comes into the first quadrant for 5 times. So that is 5 items. He uses this kind of pattern and use this one to 1 time and this one 1 time, and no actually come into the quadrant 4. So for this person, if we do this kind of calculation, so we'll say this person, the most likely to have this kind of pattern using the quadrant 1 pattern most in when he solved the items. But if one person, he comes into this kind of analysis and to say he has 1, 2, 1, 3, 4, 4, 3, like to say he comes into the first quadrant by 2 times, and quadrant 2 only 1 time, and quadrant 3 2 times, and quadrant 4 2 times. So that means this person is not that stable because he changed by different quadrant through these 7 items. So for these kind of people, we will put them into the group 5. So that means this is an inconsistent pattern for such kind of people. And so the results coming from the study 1, we can see actually for the majority of people, actually they are located in the G1 to G4. So that means we have over 80% of people actually located into the consistent one. So that means at least they have over half of the items using located in the same quadrant. So we can see actually in the G1 and the G3, we have the biggest sample size here. So that means we have the long sequence and the long time, and also short sequence and short time. But in the G2 and G4, so we have the very short percentage over there. And also you can see we also have almost 22% of people, they come into the inconsistent group. And for these kind of patterns within each consistency or inconsistent group, we also do the agreement, percentage agreement, and to see actually which kind of items they are showing more higher likelihood to each other. For example, in the group 3, you can see actually each item, they were showing up a very high agreement percentage. So that means, for example, the people come into the U16, they will similar into the pattern into the U02. So they'll have a 75% of the agreement to here. And we can see in the G1, so that is we use longer action sequence and longer response time, they will show a more higher agreement percentage actually approaching to the end of at the end of this testlet. So you can see actually from U16, U11B, and U23, they will have a higher agreement percentage to each other. And in generally, we can see the most stable pattern coming from the G3. So that means the people, once they choose, they want to use the shorter action sequence, shorter time, and they will keep this kind of pattern across all the testlet. But we also can find the G2 and G4, this kind of pattern is not that stable. Only for a couple of items, you will see that is quite a high agreement to each other. And for this kind of a group, we're also checking for their skipping behavior because we don't want to have these kind of things to influence us when we do the next step, when we calculate the similarity, this kind of a distance computation. So we can see actually G3 group, so that is we use a shorter action sequence and shorter time, they were showing the most skipping behavior. And actually the majority of this group, you can see they skip starting from 1 item to 7 items. So even we have people, 30 people actually skipped almost all the items over here. So in the study 2, we use the action sequences for similarity computation. So that is generating a process sequence indicator across multiple tasks. So we use the longest common subsequence to calculate distance between the individual observed sequence, that is OS, and also the predefined sequence. So you can see actually from this computation example, suppose we have these reference sequences, and also we have the individual observed sequence. So we want to get the longest common subsequence by each one, and finally to select the longest one as this person's the longest common subsequence length. So you can see actually we calculate them by each one, and finally we find for this observed person and his longest common sequence coming from the 4. And then we can give the longest common subsequence indicator. So you can see the similarity, actually, it is the length of the longest common sequence divided by the length of the reference sequence. And so that means how much we can find the common things between your longest common sequence with our predefined sequence. And efficiency, so that means we use the longest sequence, this length, divided by the observed sequence. So that means we want to check how many actions actually redundant in your sequence, not necessary to have in there. So when we match these kind of results back to our group 1 to group 5, and we find the group 4 actually showing up the highest the similarity, even though they are not stable over here. You can see actually the bar showing up to say it is a little bit larger than compared with the other ones. But we can see that is the highest one. So that means the group actually showing up to use the longer action sequences, but within the short time, they were showing up the highest similarity with our predefined sequences. And in that efficiency, actually, you can see it is not that pretty high for this kind of group. But for the G1, actually, that is the longest sequence and the longest time showing up the lowest efficiency in their group. So in our study 3, we want to mapping the behavior patterns by problem-solving competency and background variables. So you can see here, so that is the group 1 to 5. And interesting is to find in the G1 and the G3, we have the bimodal distribution. So that's a suggested respondents in these groups possibly had mixed proficiency levels while having the similar behaviors. And also we find the group 4 actually showing up the highest competency level here. And that this figure shows the age distribution by different behavior patterns. So we find in the group with the G4, so that is using long sequences but short time, so that is the youngest group. And for this group, the G2 actually, that is for the longest, that is used the short action sequences but the longest time. And also we can see the opposite right round of the distribution of their using the ICT at home and work. And this one is interesting to see. Actually, we have the gender differences very obviously to showing up in the group 2. So that is the male is over 60% actually than the female in this group. And finally, it is our background variables. We find it is similar like our expectation to say the group 4 actually showing up the highest education level and showing up actually for the final results. And so coming to the conclusions, we find actually around 80% of respondents show the consistent patterns. And also we find the people who showing up the long sequences, but shorter time actually coming from the highest problem solving competency and youngest and also highest education level and adopted the most similar strategy with the optimal sequences. But for the group with the high need groups, probably that's coming from the adults with showing up the shorter action sequences but long time. So that means this group is highly motivated but needs some further support. And of course, there will be some future studies because there's still some limitation in this study. For example, like in when we use a medium level, so that is quite an arbitrary way to define that. So currently we are working also on the latent dimensions. And so that will help us to evaluate the consistency across multiple tasks in a better way. And also we want to include more countries in the future studies and to assess the country effect on behavior consistency. So thank you very much for your attention. This is a reference. And if you have any questions, please put into the chat. Thank you.